And we have already mentioned a lot of this stuff just as we were going along. So Chapter 2 dealt in pseudocode, and whenever we hit a pseudocode concept, I usually actually demonstrated it in Java code. So we've seen most of this stuff already. So, our Java program. This is the style recommended by the book, and I can actually upload a style document that I want your code to follow. To me, it's not that important that it follows a whole bunch of picky details, but I really would like that. I really would like something up at the top that describes what the program does. Now, obviously, this one's really simple. This program prints a hello message. But just stick your name in it, your date, and what the program is. You know, assignment 2 calculates blah, blah, blah. So these are comments, and we know that comments are ignored by the compiler. A multi-line comment starts with a slash star, and ends in a star slash. Now that's all you need to make a multi-line comment is a slash star. You don't need the rest of these stars. That's just to make it look pretty. Since it's a multi-line comment, you can put 20 pages of text in there until you type in a star slash. That ends the multi-line comment. A single line comment is one that begins with slash slash. And both of these were stolen from C++. They were perfectly good conventions, so Java just borrowed them wholesale. All of our programs will have a class, at least one class. The name of the class has to match the name of the file. We should only put one class per file. You can squeeze more than one class per file if you make only one of them public, but there's no reason to do that. Sometimes I may do that up here just so that I can keep scrolling up and down and showing you something. But really, you should put every class in its own file. That's good programming. And file name has to match the class name, except the file name has .java tacked onto it. All of our classes should begin with the word public. That means that they're available to other classes and other files. If we made them private, then another class that was located in another file couldn't access this class. All of our classes, all of our assignments will have a main method, and the syntax of the main method is very specific. I should have put that as a quiz question, but then you just copy and paste. Anyways, memorize that. What this means is that this method is available outside of this class, and that's how Java starts it. If you made that private, it wouldn't be able to access this code. Static means that only one copy of this function exists. We'll get into a bigger discussion of what static means later. It means that this is a class method rather than an instance method. But you just have to have that there. Every main method has to be declared as static. And void means that main does not return a value. There is a keyword called return. If you wanted your function to return the number 10 for some reason so that another program, another function could use it, then we couldn't declare it as void. Void means it doesn't have a return statement. We'd have to declare it as type int or something that was compatible with that data. And we'll learn about methods later, but for now, we just know that since we're not returning a value out of the main method, then we declare it as void. This thing here would be if we passed in command line arguments into the program. And command line arguments are like if you type dir / question mark, it lists a whole bunch of things you can do with the dir command. You can type dir /s to get all the subdirectories and /od to sort them by date. And of course it's going to run forever because there's a lot of directories. But anyways, you get the idea. That /s and that /od were command line parameters, command line arguments. Well, you could make your program responsive to things like that as well. And in which case you would have to monkey, your program would actually have to access. This is an array of strings. We don't really know how to access arrays yet, but we're not passing in command line arguments either, so that's okay. And this is a call to a method. Since the method is in another class, it has a whole bunch of stuff in front of it. If that method was in this class, we would just call it like that. But this method is actually stored, outside of this file in another class called system. So we had to preface it with some stuff in order to access it. And you just memorize, okay, in order to print, I need to type system.out.println. The editor's pretty nice in that if you type system.out, it pops up a list of other choices you could make besides println. This is known as an argument. You could also call it a parameter, but a parameter has a more specific term. Actually, argument and parameter have two distinct meanings, but they're very similar, and so sometimes I will mix them up. So I'm not going to ask you to be very specific. I'm not going to give you a quiz question or a test question where you get wrong if you did not use them precisely. And once we start talking about writing our own methods, we'll get into exactly what the difference between a parameter and an argument is. What you pass in to your function is called the argument. So this is an argument. The argument specifies what we want printed out. And we use curly braces to denote blocks of code. That is one block of code. It is attached to the main method. We call it the body of the method. If you're used to programming in other languages, you use the word function, like Python uses the word function. We use the word method because a method is a function that's attached to a class. Well, here's our class, and we've attached one method to it. So all Java programs must be enclosed in a class. That's different than Python and C and C++. Think of the class as the name of the program. Well, but your program could have a whole bunch of different classes in it, so I don't agree with that. But right now, as long as we're writing simple programs with only one class, that's good enough. Proper style dictates that class names begin with an uppercase letter. And everywhere you see in examples in programming books and inside the Java language, the classes are the only things that start in an uppercase letter. Hello is the name of a class, so it started with an uppercase letter. System is the name of a class, so it started with an uppercase letter. I recommend you follow that convention, just so that your code looks professional to other people. But I'm not going to count you off, but I should, shouldn't I? I should be dang picky. The class heading is that line that had public in front of it. And so all of our classes will be prefaced with the name public class and then followed by the class name. Inside the class, we must include one or more methods. Well, that's not strictly true. You could make a class that actually didn't have any methods at all. But if we don't have a main method, it's not going to run. A method is a group of instructions that solves a task. If we have a really complex program that requires a lot of tasks, we may break them up into multiple methods. Kind of like, if there are several steps involved in making your dinner, you might put, you would bundle those up into different recipes. You wouldn't put the recipe for baking the pie in the same recipe as making the cake. That would be confusing the issue. You would have two recipes, one for making the pie, one for baking the cake, whatever example I used. So, the more complex your program is, the more it is a good idea to break it down into methods. But right now, at the very, very beginning, our programs will probably just be one method, and that's in the main method. And it has to have this specific header. Memorize it. If I made you open up Notepad and type in your code entirely by hand rather than use NetBeans, you would memorize it pretty quick. When the program starts, the computer, that's a kind of a silly statement, the Java virtual machine looks for the main method and begins execution at that point. Braces, they group things together. Every opening brace has to have a closing brace. The book says this, and I agree with it, and NetBeans does not. Place an opening brace on a line by itself in the same column as the first character of the previous line. So when I write code, and when the book shows codes, it will look like this. Public, static, void, main, whatever, string, args. And then I put that on a line by itself, lined up with that one. And then later, if x is equal to 1, I put this brace on a line by itself. While x is less than 10, then I put this one on a line by itself. So the braces go on lines by themselves. Now this is a really dumb program because all it does is increment a counter and it doesn't even print any output. And it's not a good program at all because this isn't enclosed in a class. But this is just an example of brace placement. That means defaults to doing this. Like that. Both of those are perfectly valid. Some people feel very passionate about this. You may work at a company where you have a very picky programmer who goes and changes the brace placement of every brace you've typed, which is a little bit excessive, but yeah. But this has a name and the other style has a name. I believe that most people call this a block placement, and I forget what the other one that NetBeans is using is called the K&R placement by a lot of people. K&R standing for Kernighan and Ritchie, who are the guys who invented the C++ language back in 1970, and all their code examples did it the way that NetBeans is doing it. So there are a lot of programmers who do it that way. Are there advantages to doing it this way? Well, one is that you just get more lines of code on the screen at the same time. So when I'm typing examples, sometimes I may modify my code to look like that. But this is probably easier to read. The problem with doing it this way, and a good reason that for teaching it the other way, is if once people learn, they want to put semicolons absolutely everywhere, even places that they don't belong. This code would not run because of those semicolons. And if we move the braces up like this, it starts to become clear why. You know, that hopefully that looks wrong. So your rule of thumb is never to put a semicolon before a brace. There's really never a time I can think of when you would put a semicolon before a brace. And it doesn't matter whether that brace is on the next line or not. It will do bad things. In some cases, it won't even compile. In other cases, it'll compile, but it just won't run. This code would compile, but it would not, I mean, even skipping the fact, okay, we're going to add a print statement to it just so that it would really do something. There. Now it would print hi 9 times. Why do I say it would print it 9 times?
Because x is equal to 1.
Yeah, it starts at 1 and it counts up to, but not including 10. So that's 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Anyways, it's going to print out hi 9 times, except now that I put these semicolons there, it doesn't do a darn thing. Here's how Java treats it with those semicolons there. What this says is if x is equal to 1, do that. Okay, great. That's easy to do. Do nothing. And then it comes down here, and regardless of whether x equal to 1 or not, it's going to come down here and start doing this code. While x is less than 10, do this. Well, that's also real easy to do. It can do that really fast. And it's going to do that forever. It's going to be an infinite loop. An infinite loop is a loop that processes, that it never exits until you kill the program, until you end the task. So if I typed this program in and ran it, not only would it print nothing, it would loop forever in an infinite loop until I close the window. So be careful where you put your semicolons. Don't put them before opening braces. Regardless of which brace placement style you choose. I am not religious about whether you put them there or there. Why did I talk so long about them? More to hammer in not to put the semicolons on the if lines and the while lines. If you do, I'm not going to yell at you and make fun of you. I will look very sad, though. Let's make this look correct. Okay. Proper brace placement that NetBeans doesn't enforce, or that whatever. NetBeans doesn't do this automatically. You found a place to change it? I never found a place to change it. If you show me how to do that, you will earn my undying gratitude. Until I die, in which case it's not really undying, is it? But I cannot find a way to change the default location of the curly braces. This question has been asked before.
I was really just there, and I don't remember what menu item I wanted to.
Look in Tools, Options, Editor, Formatting. Okay, Tools, Options, Editor, Formatting.
That's what I
Well, what do you know?
wanted. Change category to braces.
Yeah.
That drop down right there.
All right, you're hired. So, braces placement. You could, if you do that, and I'll post a link that says this, go to, Tools, Options, Formatting, change class declaration, change category to braces, and then change all these things as say same line to new line. Oh, I am so happy. I cannot contain myself.
And you'll want to turn off the special else if treatment. It looks like. That's cool.
Yeah. No, I'm not seeing the difference there.
It puts else on one and then if on its own.
Oh, yeah.
Yeah.
I don't like that. I like it with it on.
Leave that on.
Okay.
That's perfectly valid code, but I'd rather you see use else if rather than else code block if.
Okay.
Commodity. Anyways, you could still use either one, but to generate output, use system.out.println, or there's another option, just system.out.print. If you add ln, it goes to the next line at the end. If you don't add ln, it's not going to go to the next line at the end of the output. You can still get it, you can still force it by printing a new line character. That'll force it to go to the next line. There's also an option called printf, which stands for formatted print, which we will also talk about. You may see me giving examples of those. The syntax is that. We know the syntax. We've already used it already. I'm pretty sure we've already talked about identifier naming rules. Letters, numbers, $signs, underscores are all legal characters. The first character cannot be a digit. Can't put spaces in your variable names or your method names. And then here's some suggestions. They don't want you to use underscores. They don't want you to use $signs. Well, a lot of people like underscores, especially back when programming languages were not case sensitive. That was how you separated the words in your variable names. So you'll see a lot of code that still has underscores. I don't care which way you use it. But the book recommends that you use no underscores, and then if you're going to tack on multiple words, you just capitalize the first letter of every word except the first. Days, in, month, first name. If it's a class name, you do go ahead and capitalize the first letter, and then you still follow the initial rules. Capital S, capital R, capital W, capital S, and this is known as camel case because it's got a hump in the middle. I didn't make that up. Variables. Variables hold data. They can only hold one kind of data. Java is a strictly typed language. Strictly typed means that once you declare a variable, you have to store data only of that type in it. There are some exceptions perhaps, but just consider that a rule. Int x. X is equal to hello. That's an error. Won't work. Whereas in Python and JavaScript, you can do things like this. You could say x is equal to 3. And then you could turn around and go, well, I don't want x to be I want that to be the word hello. And then I want this to be, the current user coordinate of the mouse. Whatever, You can just mix and match in a loosely typed language. But C, C++, Java are strictly typed languages. And the reason they're strictly typed is because they are compiled languages. Well, this isn't. Makes the programs more rigorous, I should say. It lets you know that when you're programming it, you know absolutely sure what kind of data is stored in it, and the compiler knows what kind of data is stored in it. And then it can do some error checking that a loosely typed language cannot. And it won't compile if you get things wrong. Variable declaration. You give it a type, like int, string, float, and then a list of one or more variables separated by commas. We could do string first name, comma, last name. But if you want to put a comment next to each one, you may as well put them each on their own line. Here, row and column apparently need no description, so we tacked them onto the same line. If you want to initialize them, give them a starting value, you can do that while you declare them. I like this. Style, comments must be aligned. Yeah, and then you go and you change the name of the variable. Last username. They're no longer, whatever. You don't try to make your code easy and pretty to read. Java uses the equal sign to assign, and it uses double equals for comparison. And if you mix them up, the code won't compile. The single equal is called the assignment operator because it assigns a value into the variable. This assigns 50,000 into a variable named salary. This assigns the result of this expression, and this is a lengthy expression that contains, I see at least 4 different operands in it. This entire thing is evaluated, and then it is assigned, the result of that is assigned into that variable. So when I say operands and operators, the operators are the symbols. Here's an operator. This looks like an operator, but it's not really because it's inside a string. And things inside of a string, the computer doesn't know what's in that string. You could put Barney, in that string rather than, like that. Computer doesn't care. But there's a concatenation operator. It's called concatenation because it's next to a string. If it was next to two numbers, it would not be concatenation, it would be an addition operator. Here is a multiplication operator. These are both binary operators, binary not meaning zeros and ones, but that they require 2 operands. Operands are the pieces of data on either side of the operator. This guy requires 2 operands, multiply, because you've got to multiply 2 numbers together. You've got to multiply that by that. That is resolved according to the rules of PEMDAS, parentheses, multiplication, division, addition, and subtraction. This gets done first, and then the results of that get concatenated to that. Once all that calculation is done, then it is assigned to that. Forgive me if I skip past the tracing exercises. I do very little tracing by hand. It's far more efficacious to go into the debugger and then trace it right in the program. So an initialization is when you declare the variable, which is this part of it, and give it a starting value, assign it a starting value at the same time. If I go too fast, let me know. I teach 4 different programming courses. A lot of them use the same words, and I try to remember exactly what we've covered. But it's possible that I've lectured about, floating versus int in one class and not another, and then I go into that one, and I think I already have. So please slow me down, okay? Numeric types, int versus long. Ints are 32 bits long. They can hold a number up to about 2 billion, or be in the range -2 billion to +2 billion, a little bit larger. Longs are 64 bits long, so they can hold vastly larger numbers. 9 to the power of 18, so a 9 followed by 18 zeros. Big number. That might almost hold the United States dead. That a int would not. Recommendation: use smaller types for variables that will never need to hold large values. If you're asking for somebody's age, you don't need to store it in a long. That'll just confuse another programmer who looks at it. Wow, is that number really going to get that big? Who's going to grow to be more than 2 billion years old? So unless you're recording the ages of fossils or stars or something, just try to pick data types that match the data that you're holding. Just for clarity. Your program would still work if you stored absolutely everything into a long. And then there's floats versus doubles. Floats are floating point data types. Floating point data types mean that there's a point in it. It can float. It floats around. Inside the code, inside the programming language, inside the computer itself, inside the chips, there are 2 portions for every floating point number. There's a mantissa and an exponent. And so the number 3.5 times 10 to the 6 has 2 specific values. It has a 3.5, that's the mantissa, and it has the exponent of 6. That is how it's stored inside the computer, except it stores these as binary values. So there's some binary value times 10 times 2 to the power of whatever. So the fact that floating points are stored in powers of 2 rather than powers of 10 mean that you can get some imprecise answers. You can get rounding errors. So you might expect your calculation to end up being 4, but when you print it out, it says 3 point followed by 10 nines and then a 6. You go, it does not equal 3.9999996. It should equal 4. That's just a rounding error because inside the computer, floating point numbers are treated with a mantissa and then an exponent of a power of 2. There should be a really easy case that would demonstrate the rounding error. Here's your example. So A is equal to 0.7. B is equal to 0.9. I'm going to change this code a little bit. I'm just going to say A is equal to A plus 0.1. And B is equal to B minus 0.1. Then it's going to print out whether A is equal to B. You would expect those to be true. Let's print out both of those values, by the way. System.out.println A equals plus A, and then we will print B out as well. So to the human eye, they should match exactly. However, 0.1 added to something in 0.1 when you're dealing in powers of 2 rather than 10. There we go. So 0.9 minus 1, according to the computer, did beautifully and decided that it was equal to 0.8. But 0.7 plus 1 plus 0.1, for some reason, I mean the reason is that it keeps track of the data in powers of 2 rather than powers of 10 if it's a floating point type. So in order to do a comparison, you can't just use equal if you're doing floating points. Instead, you have to check for a range. You have to decide how precise you want them. So let's say that we are okay with a rounding error of like 0.01. So I'm going to declare a variable called range. And we're getting kind of far afield here, but this is an important point. I don't mind mentioning this. So we would do if b is less than a plus the range, and b is greater than a minus the range. There's a better way of doing it than that. If the absolute value of a minus b is less than the range, what? It's not math.abs? Delta is equal to math.abs of a minus b. If delta is less than the range, then we will print close enough. And I'm sorry, I didn't see the error. I know you were just telling me what the problem was, but I goofed. I didn't see it, so I broke it into two statements. Close enough, though. Now it's going to work. What we have done is we declared a variable, a value that indicates what level of uncertainty is acceptable. And in this case, the numbers are equal if they're within 0.1 of each other. Now we might want that to be much more precise. 1 out of, let's see how many zeros we got. 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever. If they are within 1/billionth of each other, then they are close enough to be considered the same. There we go. Close enough, though. So you had spotted the syntax error?
Yeah, I think you were missing an opening parentheses.
Okay. I should have had you come up here and tell me. Note that floats and doubles store their values as powers of 2. So rounding errors you might not expect can occur. To compare two floats or doubles for equality, you should actually check a range of values. One example is below. A delta is just a fancy word for difference. In physics and engineering or whatever. That's the delta of 9 and 10 is 1. And again, since floats are 32 bits and doubles are 64 bits, then a float can hold a much smaller precision value. I'm surprised they don't show those maximum values there, but we can print them out. System.out.println float.max value. and then system.out.println double dot max value, not min value. Why did I capitalize these? These are actually classes. They are known as helper classes. They give you functions that make it easier to manipulate floats. Floats and longs and doubles are known as primitive data types. They started with a lowercase letter. Every data type that starts with a lowercase letter is considered a primitive data type. It's built into the language. Everything else is an enhancement to the language. And floats are classes that are enhancements that make manipulating floats or doubles easier. And in this case, float.maxValue is a constant defined within the float class that specifies the largest value a float can hold, in case you need to know. And there we go. The largest value for a float is 3.4 times e to the 38. So that's about 3 followed by 38 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And then a double holds almost 2 times 10 to the 308. A much larger number. And notice the difference in precision. This one can hold about 1, 2, 3, 4, 5, 6, 7, 8 digits of precision, meaning the mantissa can be up to 8 digits long. The mantissa of a double is almost twice that. More bits are devoted to the mantissa. So not only can these numbers get larger, but they can get much more precise if you use doubles rather than floats. And you may as well just use doubles all the time unless you have a strong reason for using otherwise. Yeah, there's that range. This specifies a minimum and this specifies a maximum, but you could also consider that that 308 probably can go out to negative 308. So you could have a point followed by 300 zeros and then your number 1. So it can hold very small numbers. 6 significant digits for a float, 15 significant digits for a double. Why not use double all the time? Changes. Remember what I said about you have to store data of the same type in a variable? You can get away quite often with storing data of a different type, assigning it. This, for example, is legal. I could say x is equal to 10, and then I could say L is equal to x. That copies the value of that integer. I'm going to change that to I. That copies the value of that integer into the variable L. No problem. There's twice as many bits in that long. It can comfortably hold that. But you can't do the reverse without casting it. If I did this, there's a possibility for data loss. Since this number could conceivably be far larger than could be stored into an integer, the compiler won't compile it. It'll generate an error. And I know I've talked about this before. Compiler error there. But you can fix that by, and I've already said this, I am sure, what do? Maybe I haven't. You cast it. You say, it's really okay to take this long and convert it to an int. And you do that if you're sure that the result is going to be valid. And it's okay to do that. But you're telling the compiler, I'm okay with the risk of data loss because I'm pretty sure, or I'm quite sure, that long is a number of 2 billion or less. So let's give an example of what it looks like when you say that is legal, but it's not. Okay. So there's our two data types. I like X better. It shows up better in our text here. So we're going to say that long is equal to a number larger than 2 billion. We're going to say it's equal to 3 trillion. So instead of 9 zeros, I need 12. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now we're going to try to copy that into an int. I is equal to L. This number is giving me an error because I did not suffix it with the letter L. When your literal constant, when your literal number that you're typing in is larger than 2 billion, the compiler doesn't understand what it is unless you say, oh, by the way, this is really a large. All right, now that's going to be an error. If I go and look at the error, it says incompatible types, possible lossy conversion. The loss could occur if the value of L is too large, larger than the maximum capacity of an int. But we can fix that. We say, no, I'm cool with it. You go ahead and do it. And then you run it. Oh, I need to print it out before that does any good. System.out. Whoops, where'd that come from? Print line L equals plus L. The same for X. And why do I use capital L here when the rules yell over and over and over that your variables should not start with a capital letter? It's just because a lowercase l looks a lot like a 1, and it also looks like an uppercase I. So I just use L when I have a single letter variable name that I want to demonstrate to you the properties of a long. Okay, here we go. Well, before it got cast into that int, it was equal to 3 trillion. After it was cast, it equaled, that looks like 2.1 billion. Sometimes you'll see the number go negative. Let's add some more zeros to that. Alrighty, see, again, we did lose data. What if we make this a whole bunch of 9s? Apparently I'm not going to get it to go negative. But you can. So you can get data that completely doesn't make sense when you do a cast. Why do you use casts? Well, if you have a value that's stored in a format larger than what you need to store it in, to pass to a method or something that will only accept ints rather than longs, then you do that. So your rules for conversion. These are called implicit conversion. You can convert from a smaller type to a larger type, no problem. If you want to do ints copied into a long, that's great. You want to copy an int into a float, that's also totally cool. However, longs can't go into an int without casting, and longs can't go into a double without casting. I could be wrong there. Let's find out. Let's make a double. And we're going to try to store the value of that long into the double. Okay, cool. So ints can go into floats, int can go into longs, and ints can go into doubles. All just fine. The reverse is not true. Floats can go into a double just fine, but the reverse is not true. Int float types can never go into an integer type. So that tells us why the reverse of these is not true. You can't copy a float into an int. You can't copy a double into an int. Because, since they have floating point parts, 3.14 could not be copied into an int, because an int could only hold the 3. If you have to do any of these, illegal implicit conversions, you use casting. If you do something like this, int x long L, and then you say L is equal to 3, this is called promotion. Small data type is being promoted to a more precise, larger data type. Promotion is okay, and the compiler will do it implicitly. But if you tried to do the reverse, long is equal to 3, 3L, and then x is equal to long, nope, because this is demotion. Demotion is a large data type being demoted to fit into a less precise, smaller data type. Demotion only is allowed with a cast. And so the general rule is that ints can go into longs, they can go into floats, they can go into doubles. But longs cannot go into ints. Longs can go into floats and they can go into doubles. However, they cannot go into ints. Floats can go into doubles, but they cannot go into longs or ints. And doubles cannot go into any of the above unless you cast. So this is the promotion list, sequence, hierarchy. I like hierarchy. That's a fancy word. I hope I spelled it right. Might be EI. Anyways. Constants. Constants, to declare a constant, you use the keyword final. Or you just type in a number. If I'm typing some code, this number is a constant. Nothing goes in and changes that number. Once it's copied into a variable, you can change it all you want. That's what's known as a literal constant. You can also just use the word literal. It's a numeric literal. Why is it called a constant? Well, because it's hard-coded in the program. Nothing's going to go and change it unless some sneaky thing goes and changes the bytes and stored on your hard drive or something like that. The code will never change this value, but it could. Once you copy it in a variable, it's certainly a candidate for being changed. So you could do final double pi is equal to 3.14159. This tells the compiler that pi is a constant that is not supposed to be changed. If you try to change it, if you pass a law in your land saying that pi is really equal to 4, it won't let you do that because it was declared as final, and the error will indicate as such. Cannot assign a value to a final variable. The C language and C++ and a lot of other languages use the word const rather than final. No, can't reassign a final. Alrighty, we need to stop. We have finished chapter 2. We need to think about what kind of homework assignment you might enjoy doing. Let's go look. Or did I already assign them? Did I make chapter 2 homework? I almost think I did. Let's go look. Nope. We only have chapter 1 homework. Chapter 2A. Where'd 2A go? I guess I didn't do it. Is that what happened? Yeah, there he is, right there. Okay, we have assigned 2A. Let's look to see what 2B is. Or not 2B. Here we go. I am so funny. Assignment 2B. Write a program that will count from 1 to X where the user specifies X. Remember how to get user input. You use a scanner. Scanner in is equal to new scanner system.in, and then you use x is equal to next in.nextInt. Something like that. That's just a reminder. And then print each number out. So if they type in 10, you're going to print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If they enter 20, you're going to print all the numbers up to 20. So you'll use a while loop for that. Print each number out. Allow the user to repeat the program or to exit, either with a Sentinel value or a user query. Remember we talked about the two different types of loops. Actually, I think we did 3 different types of loops. There are, oh gosh, I cannot believe that I can't remember the name of the first one. The first one is the one where you know the number of iterations ahead of time.
Count.
Yeah,
Yeah.
counter loops. The second is when you have a user query. The user says, or the program asks, do you wish to continue? We're querying the user, and if they choose yes, then it runs again. If they don't, then we don't. The third option is a Sentinel value, where we say enter X or -1 to quit. So here's an example showing user query. And here's an example showing Sentinel value. I almost don't want to put this in the same document, but an example of one versus an example of another. We're going to change this from 1 is y and n. No? Okay, so string repeat is equal to ey, while repeat dot equals, that's how you compare strings, by the way. That's why I'm giving you an example here, because we're doing stuff that we're actually depending on stuff that's later in the book, but it's similar to stuff we've been doing in class. I feel comfortable giving this to you, but if you get confused and text me, and I sense lots of problems with it because you let me know, then then we will extend the due date, or I'll give more examples or whatever. So anyways, then you're going to do some stuff. Do some awesome stuff. Then print a message. Print, do you wish to repeat? Y, n. Let's even change that to print line. Then we get that input in. Repeat is equal to scanner.next. That reads the next string that they type. If they type in a Y, the while loop will repeat, and it'll do some more awesome stuff. But if they type in anything else other than a Y, they won't. So here's code example for a user query loop. Here is code example for a Sentinel value loop. And this is the easiest way that I know how to code a Sentinel loop, but there are other ways. What you do is you ask the user for input of whatever kind. Print line, what is the value of blah blah blah? If you have enough courage to actually turn in something that has that line in it. No, I'm kidding. Then, or you tell them that they have the option of quitting. And you could of course put it all on one line. Or -1 to quit. Whatever you wanted to make the quit, and then you check. You know what? We don't have to use a break statement to do this. Okay, so while value is not as greater than or equal to 0, we will ask the user for some input, and then if they type in a number that's greater than equal to 0, we will actually do that work. In this case, it would be looping. Example, the loop that prints those numbers. But if they did type in a number less than 0, then we would exit. It would fall out of that loop. Okay, hopefully with those 2 examples, this program should be a piece of cake. If it's not, let me know. I recommend that you try to get it done by Monday or before so you can ask me about it on Tuesday. But like I said, if people are confused about it, I can extend the deadline. I don't really think people are. Will be. Certainly ask me if you do. We will paste this into a better form of instructions than what we already have. Take roll and be done. So here's our examples, page break. Here's our code examples, page break. And we'll make this due Wednesday at 11:59. I can format that later while you're not waiting.